We will see one more example. Yesterday we have discussed about partial differentiation. Some examples we have seen. One more example. It is basic example to understand the partial differentiation, how it is. Okay. So let us see this example. So z cube minus zx minus y equal to 0. We have now ensure that this z square, dabba square z by dabba x dabba y is equal to minus 3z square plus x upon 3z square minus x bracket cube. Now here this z is what? Z is a function of x and y. Z is a function of x and y. This is a composite function of x and y. So that we need to keep in mind. Okay. So now first what we have z square. Now consider the given z cube minus zx minus y equal to 0. Call it as 1. Now differentiate this one partially with respect to x and y. Okay. So differentiate equation 1 partially with respect to x and y. Okay. Why we are differentiating this with respect to x? Because we want dabba square z by dabba x dabba y. Okay, so if we apply dabba by dabba x of dabba z by dabba y, so what we get this is nothing but dabba square z by dabba x dabba y. So we need dabba z by dabba y, also we need dabba x dabba by dabba z by dabba x. So let us just try to find out that values. What is that? Okay, so what is the derivative of z cube? What is the derivative of z cube? It is 3z square. Okay, because z is a function of x and y, therefore it is a composite function, and 3z square into again derivative of z with respect to x. First we are differentiating partially with respect to x, minus here u into v rule. Okay, because z is a function of x and y, so x as it is, derivative of z is dabba z by dabba x plus. Okay, so what is that? Plus z as it is, sorry, in the bracket it become minus, is plus z as it is, derivative of x is 1, minus derivative of y is 0, with respect to x it is 0. Have you got this? How I have taken this? Okay, because z is a function of x and y. What is the partial derivative of z with respect to x? It is dabba z by dabba x. Partial derivative of z with respect to y is dabba z by dabba y. It is not a constant. See here z is not a variable. One more thing. Z is a function of x and y. Okay. So as z is a function of x and y, we need to differentiate it again. Isn't it? Okay. So now this is the derivative of this. Let me explain it once again, because this is very important to understand the derivative. So derivative of z cube is 3z square into dabba z by dabba x. Because z is a function of x and y, we need to take the derivative of z partially with respect to x, minus. Now here it is u into v rule. X as it is, derivative of z is dabba z by dabba x, plus z as it is, derivative of x is 1, u into v rule. Okay, minus derivative of y is 0 with respect to x. So that's it. And now what I get, dabba z by dabba x, 3z square. If we simplify this, dabba z by dabba x minus x into dabba z by dabba x minus z. This is equal to what? 0. Now shift this z into that side. Z इकडे घेऊ, काय माहित आहे बघूया. And in this first two, what is common? Dabba z by dabba x is common. So what is in my bracket? It is 3z square minus x into dabba z by dabba x. This is equal to plus of z. And if we want dabba z by dabba x, so how, what is that? This imply dabba z by dabba x is nothing but z divided by 3z square minus x. Are you getting this? Yes. Okay, so this is the value of dabba z by dabba x. Now, what is the partial derivative of this function 1 with respect to y? Okay, so it is similarly with respect to y is how it is. See, it is 3z square again into now dabba z by dabba y. Okay, minus x is constant as it is. There is no u into v rule because x is constant as it is, because we are differentiating partially with respect to y. Therefore x is constant and derivative of z is dabba z by dabba y. Minus y is there and derivative of y is what? 1. This is equal to 0. Shift that 1 into that side. This is dabba 3z square minus x into dabba z by dabba y. This is equal to what? 1. And from this what I get? I'll get dabba z by dabba y. This is equal to 1 upon 3z square minus x. Got it? Now come to the original thing that we want. Okay, actual thing that we want, it is dabba square z by, see what we have to find. Show that this dabba square z by dabba x dabba y is equal to this RHS. Okay, so consider that dabba square z by dabba x dabba y. Consider dabba square z by dabba x dabba y. This is equal to dabba by dabba x of in bracket dabba z by dabba y. Substitute the value of dabba z by dabba y. Now it is here. See, in this box we have dabba z by dabba y. So dabba by dabba x of, in the bracket it is 1 upon 3z square minus x. So this is 1 upon function. What is the derivative of this d dx of fx? 1 upon fx. It is 1 of minus 1 upon fx square into f dash of x. Isn't it? Okay, so this is the partial derivative. Now function is nothing but it is in the denominator, so the answer is minus 1 upon bracket square function square. Function is nothing but 3z square minus x bracket square into partial derivative of this 3z square minus x, isn't it? Okay, so this is the partial derivative dabba by dabba x of this function f dash of x. Okay, now this first thing as it is 1 upon 3z square minus x bracket square as it is. Now find out the derivative of this. 3 as it is, derivative of z square is 6z, means 2z, means it is 6z into dabba z by dabba x minus derivative of x is 1. Okay, so see, just note this step how I have taken the derivatives. This is simply what? This is minus 1 upon 3z square minus x bracket square. Now what is inside the bracket? What we need to find, need to replace? What is the value of dabba z by dabba x? It is z upon 3z square minus x. This is nothing but z divided by 3z square minus x. Okay, so this is z upon 3z square minus x, minus 1 is there. Now just simplify the bracket and finalize the answer. Okay. Now what I get here, so this is equal to minus 1 upon 3z square minus x bracket square. Inside the bracket take the LCM, 6z into z is 6z square minus 3z square minus x ने 1 ला multiply करा. This is 3z square minus minus plus x divide by This is 3z square minus x as it is. See here, if we combine these two, we'll get 3z square minus x bracket cube, and 6z square minus 3z square is nothing but 3z square. Okay, and therefore the final answer is what? This is minus 3z square plus x divided by 3z square minus x bracket, and that way that I want, sorry, bracket cube, because this is square and this is raised to 1, so 2 plus 1 is nothing but 3. That is my answer, and hence the proof. We shows the result. Okay, so see here, it is minus 3z square plus x divided by 3z square minus x. Hope you understand this. Is there any doubt in this example? Okay, so let us move forward to the this partial derivative of a composite function. Okay, you know the composite function. What is meant by composite function? What is meant by composite function? If x is a function of t, okay, and t is a function of y, then x is the composite function of y. Am I right? So this is the meaning of composite function. So here, suppose if we have a two functions, okay, and how actually we can find out? Suppose z is a function of u, and u is a function of x and y. Okay, so let z is a function of u, and u is a function of x and y. Then, okay, then what I get? Dabba z by dabba x is equal to dabba z by dabba x is what? It is nothing but, you know the chain rule for the composite function, dabba z by dabba u into dabba u by dabba x. Am I right? And what is dabba z by dabba y? This is nothing but dabba z by dabba u into dabba u by dabba y. This is the composite function of these two functions. Of the function z is equal to f of u. Chain rule माहिती आहे आपल्याला. So suppose that chain rule we have used here. This is a chain rule. This is nothing but the chain rule that you have studied in the 12th standard. Am I right? Suppose for example, if we have in the ordinary derivative, what is that? Suppose if we have z is equal to sine of xy. Okay, suppose z is equal to sine of u, for example, and u is equal to x into y, x plus y, suppose. Okay, then see, z is a function of u and u is a function of x and y, isn't it? So therefore z is a composite function of x and y in this way. And if you want the derivative of z with respect to x, then it is dabba z by dabba u into dabba u by dabba x, like this. So it means what is the derivative of z with respect to u? It is cos of u into again derivative of u with respect to x, so dx of x plus y, like this. And simply it is nothing but cos of u, isn't it? See, in this way you can find out the composite partial differentiation of composite function. Let us see that how it is. Let us see example on this. This is also important example. Suppose if we have x is equal to cos theta divided by u, and y is equal to sin theta divided by u. Okay, evaluate. What we need to evaluate, it is dabba x by dabba u suffix theta. What does it mean? It means treat theta as a constant. Okay, the meaning of suffix theta is nothing but, while finding the partial derivative of x with respect to u, treat theta as a constant into, it is dabba u by dabba y, sorry, dabba u by dabba x, treating y constant, plus it is dabba y by dabba u, treating theta constant, into dabba u by dabba y, treating x as a constant. So this need we need to find. Okay, हे आपल्याला विचारलंय तर बघूया वन बाय वन. x आणि y दिलेले आहेत. x is given. So the first thing that we can easily find out derivative of x with respect to u and derivative of y with respect to u. These two things are obvious. The ही term आणि ही term तर लगेच मिळून जाईल. For the another two terms we need some adjustment. Okay, that we'll discuss. So first of all, see x is given. X is equal to cos theta upon u. So therefore differentiate, call it as 1. 1 partially with respect to is what u. Okay, treating theta as constant. Take this theta as a constant. So how I get this dabba x by dabba u, isn't it? So this is dabba x by dabba u is nothing but dabba x by dabba u treating theta constant. This is equal to, what is that? Cos theta is constant as it is, and what is the derivative of u? It is 1 upon u square, minus 1 upon u square. So my answer is minus cos theta divided by u square, isn't it? So call it as equation number 2. We'll just use this in the final answer. Okay, now what is y? Y is nothing but your sine theta upon u. Again differentiate this with respect to what? Differentiate y with respect to u, treating theta as constant. Take this theta as constant. So what I get here, dabba y by dabba u is equal to, treating theta constant. Suffix theta means what? We just treat theta as a constant. This is equal to 1 upon u. Derivative of 1 upon u is minus 1 upon u square and sine theta as it is. So this is minus sine theta divided by u square. Call it as equation number 3. Now we have two things. It is dabba u by dabba, dabba x by dabba u treating theta constant, and dabba u by dabba y treating dabba y by dabba u treating theta constant. Now the remaining things. So to find out the remaining things, we need to do some manipulation. So we just remove the theta. Okay, see, while finding the partial derivative of u with respect to x treating y constant, we need only these three terms in the expression. Which three terms? U, x and y. We don't need theta. So just try to remove the theta. Okay, so partial derivative of u with respect to x treating y constant, we need to remove the y. Sorry, we need to remove the theta from the given expression, and whatever that expression we have, partially differentiate that with respect to x treating y as a constant. So how do we remove that theta from the given two expression, and we will get the new expression. So if we square and add 1 and 2, what I get? Sorry, 1 and 3. Suppose this is, see, if we take this as x square plus y square. So next consider x square plus y square. What I get? What is x? X is nothing but cos theta divided by u, its square, plus what is y? It is sine theta divided by u square. We are trying to remove the theta. Okay, so what is that? It is cos square theta divided by u square plus sine square theta divided by u square. Now LCM is same. Take the addition of numerators. This is cos square theta plus sine square theta. Divide by u square. Am I right? Yes or no? Okay, so this is very important to remove the theta, and how to remove the theta. This is the procedure that we have. So this is upon u square. What is cos square theta plus sin square theta? Cos square theta plus sin square theta. What is the value of this? Okay, so this is 1. This is nothing but 1, and what we have, x square plus y square is equal to, and therefore x square plus y square is equal to 1 upon u square. What we want here, dabba x by dabba u treating theta constant. Okay, and sorry, dabba u by dabba x and dabba u by dabba y. So from this we can also find out the expression for u. So what is that? It is nothing but u square is equal to 1 upon x square plus y square. Okay, or we can write this as, this can be also written as u square is equal to 1 upon x square plus y square. Call it as equation number 4. This is very important equation. U square is equal to 1 upon x square plus y square, isn't it? So with the help of this expression, see, there is no theta in this expression. We just merge that two equations, whatever we have from the example, and we'll get the new expression which do not contain theta, and this will help us to find out what the remaining two terms. Okay, so now partially differentiate this 4 with respect to x, treating y constant. See here, treating y constant, this thing, dabba u by dabba x treating y constant, and dabba u by dabba y treating x constant. Okay, so therefore after that partially differentiate this 4 with respect to x, okay, and y respectively. What I get, this is nothing but what, derivative of u square, it is 2u into dabba u by dabba x with respect to x. This is minus 1 upon x square plus y square bracket square into 2x is there because it is with respect to x. This is nothing but 2 get cancel on both sides. Okay, so this 2 and 2 get cancel, and what is that, it is nothing but this imply, this is splitting y constant, dabba u by dabba x splitting y constant, this is equal to minus x divided by u is there, this u shift into the denominator, u into x square plus y square bracket square. This is the thing, call it as 5. ही एक व्हॅल्यू झाली आणि विथ रिस्पेक्ट टू y पण जिथे x आहे तिथे y रिप्लेस करूया. So what I get, this is, and dabba u by 2u into dabba u by dabba y treating x constant, this is equal to minus 1 upon x square plus y square bracket square into 2y. Again 2 get cancel on both sides, and what I get here, it is dabba u by dabba y treating x as a constant, this is nothing but minus u, sorry, minus y divide by u into x square plus y square bracket square. Call it as equation number 6. Okay, so this is what, this is the partial derivative of u with respect to y treating x constant. Now all the terms we have. Okay, so substitute that values, consider that required thing from the equation, from the example. Okay, and substitute all the values. Now consider is that, consider this and substitute the values. Okay. This is dabba y by dabba u treating theta constant, and this is Okay, so what is dabba x by dabba u treating theta constant? Dabba x by dabba u treating theta constant. Where it is dabba x by dabba u treating theta constant minus cos theta upon u square. Okay, so this is minus cos theta upon u square into dabba u by dabba x treating y constant. Dabba u by dabba x. It is from equation number 5 minus x upon u into x square plus y square. So this is minus x divided by u into x square plus y square bracket square plus dabba y by dabba u treating theta constant. It is simply what? Minus sine theta divided by u square, and this is nothing but what? Minus y divided by, from equation number 6, that we have u into x square plus y square bracket square, like this. Now just try to simplify this and you will get the final answer. This is equal to minus minus become plus x cos theta is there. Okay, this is x cos theta. Denominator is same, divide by u into u is u square u cube into x square plus y square bracket square, minus minus become plus, it is y into sine theta, divide by, this is again same, u cube into x square plus y square bracket square, like this. Okay, and this is equal to, LCM is same, take the addition of numerator x cos theta plus y sin theta, divide by, this is u cube into x square plus y square bracket square. But what is x square plus y square? See, x square plus y square is nothing but 1 upon u square from equation number 4. Okay, so we can substitute that value here. It is 1 upon 4, and here it is. This is equal to, and what is x cos theta? X is nothing but what? What is x in the given in the example? X is nothing but cos theta upon u. Okay, also substitute that value. U is, x is nothing but cos theta upon u into cos theta plus y is nothing but sin theta upon u into sin theta, as it is. Okay, see, x value of x is nothing but, see here, it is cos theta upon u, and value of y is nothing but sin theta upon u, that I have replaced. तुम्ही हवं तर इथे लिहू शकतात राईट हँड साइडला. So it is cos theta, x is equal to cos theta upon u, and y is equal to sin theta divided by u. Okay, so and what is in the denominator? In the denominator there is u cube as it is into 1 upon u square bracket square is there. Okay, because x square plus y square is nothing but u square. X square plus y square is nothing but 1 upon u square, that value I have replaced. This is u cube, and now what is there into the numerator? It is cos theta into cos theta is cos square theta. Okay, so this is nothing but cos square theta plus sin square theta divided by u. So this is cos square theta plus sin square theta upon u is there, whole divided by, what is here? So u cube into 1 upon u raised to 4, like this. Okay, so u cube get cancelled, this u cube get cancelled, only 1 upon u is there, and that 1 upon u is cancelled with this. Okay, and cos square theta plus sin square theta is nothing but 1. So my final answer for this is nothing but 1. Do you get this? Any doubt? just some important things are here. So you need to constant treat as a constant. Okay, that is very important. So treat as another variable, you have to treat as a constant while finding the partial differentiation. And it is also very easy because what here given that which variable we need to treat as a constant. So dA by x by dA by u, it means what we need to treat theta as a constant. Okay, so basic thing is what if you want the partial derivative of x with respect to treating theta constant, so just try to remove y from that equation. We don't want y. Okay, so if we want dA by u by dA by x treating y constant, then we don't want theta in that. ओके एक्सप्रेशन त्या एक्सप्रेशन मध्ये थिटा नकोय ज्या वेळेला तुम्ही डॅबा यू बाय डॅबा एक्स ट्रिटिंग वाय कॉन्स्टंट करताय म्हणजे तीन व्हेरिएबल पाहिजे कुठले कुठले एक यू पाहिजे u x आणि y पाहिजे वी डोंट वॉन्ट थीटा ट्राय टू रिमूव द थीटा समजा तुम्हाला डॅबा यू बाय डॅबा वाय बाय डॅबा यू फाइंड करायचे विथ रिस्पेक्ट टू थीटा जस्ट वी डोंट वॉन्ट एक्स एक्स नको एक्सप्रेशन मध्ये एक्स काढून टाका रिमूव्ह करा त्याला जसं आपण थीटा रिमूव्ह केला असं गॉट इट एनी डाऊट नो okay fine now kind of example. So suppose if we have a u is equal to mx plus ny, u is equal to mx plus ny, and v is equal to nx minus ny, where m and n are constants, where m and n are constants, find the value of, find the value of dA by u by dA by x treating y constant. Okay, then into dA by y by dA v, dA by y by dA v treating x constant into dA by x by dA u treating v constant into dA v by dA y treating u constant. Okay, so this is the example. Now here, see two things we will get directly. Which two things we will get directly? DA by u by dA by x treating y constant and dA by v by dA by y treating u constant. Okay, so because see if we want dA by u by dA by x treating y constant, here we have u x and we just treat y as a constant. Okay, and if you want dA by v by dA by u by dA by y, dA by v by dA by y treating x as a constant. Okay, see this is not actually this thing that we will get dA by y by dA by v treating x constant. Sorry, dA by which one? Just a minute. dA by v by dA by y treating u constant. Okay, yes. These two things we'll get directly because we don't have the confusion about that. U चा डेरिव्हेटिव्ह तुम्ही विथ रिस्पेक्ट टू एक्स काढू शकता डायरेक्टली कारण u आणि v हे फंक्शन दिलेले आहेत. ठीक आहे. So now given is what? Given is u is equal to mx plus ny, call it as 1, differentiate partially with respect to x. dA by u by dA by x पाहिजे treating y as a constant. So what I get? dA by u by, this is dA by u by dA by x with respect to x treating y constant. This is equal to, see what is the derivative of u with respect to x? M constant as it is, derivative of x is 1 plus ny totally constant term, its derivative is 0. From this what I have, dabba u by dabba x treating y constant is equal to only m. Got it? Call it as equation number 2. Okay, fine. Now let us move forward. We want the partial derivative of v with respect to y treating u as a treating x as a constant. Okay, so as there is no uh, u, okay, so what, how we can get that? So this is dabba v by dabba y is equal to, so v is given, next v is equal to nx minus my is there, call it as equation number 2. This is my v. Okay, and what is the derivative of this dabba v by dabba y? So therefore differentiate partially with respect to y. What I get here? Dabba v by dabba y treating u constant. This is equal to, as u is not there, we need to take a constant. So nx is totally constant term, so its derivative is 0. Okay, so dabba v by dabba x dabba y. Just a minute. Okay, not like that. Dabba. Okay, there is no v. We don't want x in that, so we cannot do like that. See here, what we have to find dabba v by dabba y by dabba v treating x as a constant. So we just have to remove the. We have to find out the value of x. So from this we can easily find out the value of x. So how it is? See from this, it is nx is equal to v plus my is equal to nx, like this. Sorry, the value of y. So it is what, v is equal to nx minus ny. So therefore v my is equal to, हा my मायनस आहे इकडे शिफ्ट करा, v इकडे तिकडे प्लस आहे इकडे आणा, nx मायनस v. ओके, आपल्याला y पाहिजे, y मधलं एक्सप्रेशन पाहिजे, कारण की आपल्याला हे मिळेल मग. सो वी विल गेट दिस dabba y by dabba v treating x constant. We want the expression in y, v and x. Okay, this is the expression in y, v and x. So from this we can easily find out the dabba y by dabba v. Okay, so therefore what I get here, and shift that m into the denominator. So from this y is equal to m upon n into x minus 1 upon m into v, like this. And now just try to differentiate this, call it as equation number 3, and differentiate partially with respect to what, v. Now we can easily find out this. Now what I get here, dabba y by dabba v treating x as a constant. ही सेकंड टर्म फाइंड करतोय बघा आपण, dabba y by dabba v treating x constant. तीन व्हेरिएबल पाहिजे, y v आणि x आहेत का चेक करूया. y v x आहेत, y पण आहे, v पण x पण आहे, u नको होता आपल्याला, u इज नॉट देयर. जस्ट डिफरन्शिएट दॅट. ट्रीटिंग x कॉन्स्टंट म्हणजे पहिली टर्म टोटली कॉन्स्टंट झाली, त्याचा डेरिव्हेटिव्ह 0 आला, मायनस v पार्शियली विथ रिस्पेक्ट टू v पाहिजे, 1 upon m as it is, minus 1 upon m as it is, आणि v चा डेरिव्हेटिव्ह 1, isn't it? And therefore from this what I get, dabba y by dabba v treating x constant, dabba y by dabba v treating x constant, this is equal to minus 1 upon m. Call it as equation number 4. ओके, दोन टर्म तर मिळाल्या, पुढच्या बघूया आता कशा मिळतात. आता dabba x by dabba u पाहिजे आपल्याला, dabba x by dabba u, दिस टर्म. तर ही टर्म फाइंड करण्यासाठी काय काय लागणार आहे बघा, एक्स लागणार आहे, यू लागणार आहे आणि व्ही लागणार आहे. आपल्याला काय करावं लागेल मग, वाय रिमूव्ह करावा लागेल दोघं इक्वेशन मध्ये. Okay, we just need to remove the y from both the equations. And how we can remove that y from both the equations? So let us see that. Okay, what is the procedure to remove that? So to find dA by x by dA by u, treating v constant, express x in terms of u and v. Okay, we want the derivative of x in with respect to u treating v constant. So express x in terms of v. We want the x in terms of u and v, okay, and by eliminating y. So eliminate y by eliminating y. So how we eliminate y from both the equations? So let us see what we have. We have u is equal to what, mx plus ny. From this, what is the value of y? So u minus mx is equal to ny, and therefore what I get, this is 1 upon n into u minus m upon n into x, this is equal to y. This is the value of y. या इक्वेशन वरनं y ची व्हॅल्यू ही मिळाली. ओके, किंवा डायरेक्टली तुम्ही असं लिहू शकता, दिस इज सिम्पली दिस इम्प्लाय y is equal to u minus mx divided by n. This is the value of y. आणि याच्यावरनं पण y व्हॅल्यू फाइंड करून घ्या सेकंड इक्वेशन वरनं. v is equal to nx minus my. So from this what I get, my is equal to nx minus v, isn't it? And therefore y is equal to what? Y is equal to nx minus v divided by m. ही व्हॅल्यू मिळाली. आता हे दोघं कंपेअर करा. LHS दोघांची सारखी म्हणजे RHS पण सारखी असेल. And therefore what? Therefore u minus mx upon n, this is equal to nx minus v divided by m. Okay, just try to solve this, and after solving this what I get, cross multiplication करून टाका. So after doing cross multiplication, m into u minus m square into x is equal to n square into x minus n into v. And if we solve this for x, what I get, x is equal to mu plus nv divided by x square m square plus n square. This is the value of x. Okay, similarly if we proceed, so to find out the derivative, so what is the differentiation, dA by x by dA by u treating v constant. What is this? V constant है 1 upon m square plus n square constant as it is. U चा derivative 1 and m as it is. So its answer is nothing but m upon m square plus n square. चेक करून घ्या बघा, m as it is, u चा derivative 1, n v total constant त्याचा derivative 0 divided by m square plus n square constant as it is, like this. Okay, similarly we can remove the x from the above two equation. Similarly जर तुम्ही x रिमूव्ह केला, जसं आपण y रिमूव्ह केला आता, तसं जर तुम्ही x रिमूव्ह केला, ओके, तर आपल्याला काय मिळेल बघा, v चं एक्सप्रेशन मिळेल, बिकॉज वी डोंट वॉन्ट v. Okay, so what I get, similarly v is equal to, it is nu minus m square plus n square into y divided by m. Similarly we remove the x from both the expression, we will get the value of v. v का फाइंड करतोय आपण, कारण हे बघा आपल्याला इथे पाहिजे dA v by dA y treating u constant. For this what we want, द एक्सप्रेशन इन v y अँड u x नकोय असं एक्सप्रेशन पाहिजे आपल्याला या दोघांवरनं की ज्याच्यामध्ये x नसेल. मग x रिमूव्ह केला आपण आणि v फाइंड केला. x रिमूव्ह केला आणि v फाइंड केल्यानंतर सेम प्रोसेस जर अप्लाय केली तर तुम्हाला v हा मिळेल आणि जर याचा डेरिव्हेटिव्ह तुम्ही घेतला डॅबा v बाय डॅबा y विथ रिस्पेक्ट टू y जर घेतला ट्रीटिंग u कॉन्स्टंट तर हा टोटली कॉन्स्टंट होऊन जाईल याचा डेरिव्हेटिव्ह 0 मायनस एम स्क्वेअर प्लस एन स्क्वेअर ॲज इट इज वायचा डेरिव्हेटिव्ह 1 डिवाइड बाय एम and this is nothing but minus m square plus n square divided by m. This is the value. All the values that we have and now consider what we want. Okay, जे आपल्याला पाहिजे होतं ते consider करूया and we just replace all values. Okay, so now find out this, see what I get. So the values one by one we will substitute. Consider this. Dabba u by dabba x treating y constant काय बघूया. Dabba u by dabba x treating y constant m equation number 2 वरनं. This is nothing but m into dabba y by dabba v treating x constant. Dabba y by dabba v treating x constant. 4 वरनं minus 1 upon m मिळालं. So this is minus 1 upon m into dabba x by dabba u treating v constant कुठे इथे बघा आपल्याला मिळाला m upon m square plus n square m upon m square plus n square आणि into लास्ट वाली व्हॅल्यू ही आहे इथे मायनस एम स्क्वेअर प्लस एन स्क्वेअर अपॉन एम सगळ्या टर्म्स कॅन्सल होत आहेत बघा each and every term will get cancelled here m get cancelled this m get cancelled my m square this minus get cancelled and minus minus become plus and your answer is what plus 1 this is equal to plus